Hi, everybody. It's a pleasure for me to present at this conference. My name is Lee Margetts, and I'm going to be talking about how we're investigating using the Metaverse to develop a fusion energy power plant. Now, this project has been funded by the United Kingdom Atomic Energy Authority through a special program called the Small Business Research Initiative, and the competition is called the Fusion Industry Challenge Program. And basically, what the idea is to investigate the development of next generation digital tools that could be used by the supply chain and engineers and scientists to develop a first of a kind fusion power plant. Now, this activity involves a large team, so let me introduce you to the team. So the project is being led by the University of Manchester, and we have a number of different subcontractors and partners. So we have the University of Oxford are contributing to the project. In fact, it's the Bodleian Library, which is very interesting from the point of view of the curation and management of knowledge, which is an important part of the project. We also have a small enterprise involved in the project, a company called NT Tau Digital Limited. And this is run by Simon Woodruff, who's an entrepreneur that spent the last 20 years working in the fusion industry. We also have collaborations with the Vanderbilt University, and we're using their Metamorph software. And we're receiving support from NVIDIA and a number of different people from the UK Atomic Energy Authority. So before I get into how we're using the Metaverse, let me give a very quick overview of how fusion works. So the basic idea is that we encourage, or if we manage to get atoms of hydrogen to combine or fuse, this gives off energy and neutrons. And the byproduct, if you like, the ash, is helium. The energy in the neutrons are used to heat up water, which creates steam and drives a turbine in exactly the same way as a coal-fired or a gas-fired power station. So we're simply just replacing, one source of energy with another, but generating electricity in the same way. Now, this is the process that generates energy in the sun, and the sun benefits from very large gravitational fields, which cause the hydrogen atoms to combine. And we need to, or, in order to benefit from this energy source, we need to do this at a human scale. Now, we can't increase gravity, but what we can do instead is increase the temperature of the hydrogen. And in fact, in this reactor that we can see here, we're heating the hydrogen to around 100 million degrees or higher. Now, there's no man-made materials or human-made materials that can withstand those high temperatures. So the plasma that you can see in the purpley pink color is kept away from the walls of the power plant using magnetic fields. So this is a very, very complicated machine. We've managed to build machines like this in order to investigate the science. But in order to go from a scientific facility to a power plant, this is very challenging. There are many different areas of physics and engineering. We need to sort of design a complete power plant, but if we change the design of a particular component or system, this has an impact on all the other components and systems. And so the ideal, and this is a little bit like science fiction, the ideal would be a real-time simulation environment where an engineer could interact with evaluating many different what-if scenarios using support from AI and using very powerful supercomputers in order to, support the design process. So we don't have those tools at the moment. And what people think in the fusion community, particularly the leaders in the UK Atomic Energy Authority that came up with this Fusion Industry Challenge program, which is funding the work, they believe that there needs to be a paradigm shift in the way that we do engineering simulation. And this brings us to, the idea of using the industrial metaverse. So our starting point in our project has been to look at the NVIDIA Omniverse platform. What's attractive about this is it permits a team of engineers or scientists to share a common view of power plant design and collaborate in real time. It also has connectors for a wide range of tools that we're interested in using. And so the engineer works in their favorite tools, but the way that the Omniverse works is that the outputs of those tools are converted into a common data format, and the Omniverse aggregates these into a single scene, which is, in our case, is our metaverse. And our task is to extend this platform, adding simulation tools and engineering tools that are relevant to the fusion industry. So what we're not doing is starting from a blank sheet of paper and thinking, how are we going to build a platform, a digital engineering platform for fusion? What we want to do, because we want to develop a fusion power plant in the shortest possible time, we want to leverage existing enterprise software, tools, microservices, and extend them, bringing in engineering simulation for engineers to develop systems. And also we want to have the ability to mine who did what, when, and why in the design process, so that we can track decisions made and their particular impacts. So the metaverse is attractive because it gives the opportunity to provide an interface or environment that is specific to a particular stakeholder group. So we can have a single engineer working alone, doing a design for a particular component, or we could support a team of engineers collaborating in the design of a subsystem. And then when it comes to the development of a fusion power plant, the actual buildings and construction of the power plant, then the metaverse also offers the opportunities to bring together many different companies and stakeholders across the supply chain. So it's very appealing from this point of view. So our project is in the early stages. So, we've only been going for a few months. So what I'm going to do in the next few slides is just give, some highlights as to the progress that we're making towards our goal of an integrated digital engineering platform in the industrial metaverse. So the first thing is, how do we bring engineering tools into this environment? And so what we've done is we've taken an approach using a workflow engine. And in this example, what you can see are these little golden lines are paths that neutrons that are given off by the fusion process. These are the paths the neutrons take when they pass through the material of the power plant. And so we can do this. So we're using very, very specific software developed by scientists uh, to, to investigate these processes. Another activity that the engineers carry out is the use of engineering design tools. So here we can see on the right-hand side a computer-aided design package that a single engineer is using. And on the left-hand side, what we have is that view in the Omniverse. And the view on the left-hand side can be shared with many different engineers, all interacting and all contributing to the design process. And this has been achieved by writing a connector for a tool that didn't already exist in the Omniverse. And this, you can see, this is a very powerful activity. Another area that we're very interested in is the use of digital twins. And so there are a number of different physical experimental facilities that are used to determine the properties of different materials used in the fusion power plant, and also facilities used for manufacturing specific things. And through the industrial metaverse, what we can do is we can capture the data generated by those facilities and bring them in to the industrial metaverse and link them directly to the simulation tools and the power plant design process. Another area that we're very interested in is photorealism. So if you imagine a fusion power plant, it probably isn't a very nice place for a human being to enter. So we have robotic systems that go in and do maintenance. But really what we want to be able to do is have those robotic systems identify areas of the reactor that need attention, or components that need replacing. And before the power plant, the first of a kind power plant, is developed, what photorealism gives us the opportunity to do is to allow a virtual robot to train in a virtual environment, but in a virtual environment that is very close to reality. So sticking on the theme of visualization, another area that's of interest is extended reality. So we can see here on the bottom left-hand side a view inside a design of a fusion power plant using virtual reality. But also, what we're interested in is taking simulation results into an experimental facility and viewing them in real time, or viewing, once the power plant has actually been built, viewing data that's stored in the metaverse through augmented reality whilst we're on site. So there's a number of different attributes of the industrial metaverse that are very attractive for this particular activity. So this is the end of the part of the presentation where I'm talking about the use of the metaverse for fusion. But what I want to share with you, and this is very exciting, is that there are a number of different areas of engineering where they've got excited about our work. One of the areas is a project that BAE Systems have funded at Manchester, which is to look at the use of digital twins and the metaverse in support of their Factories of the Future initiative. So this is this activity is directly fed from the UK Atomic Energy Authority funding. The work with BAE Systems kicked off some interest with Microsoft. So we've had a workshop between Manchester BA Systems and Microsoft to look at how the industrial metaverse could be used to support the development of the next generation jet fighter. So there's an initiative called the Global Combat Air Program, which is a collaboration between the UK, Italy, and Japan. And basically, they want to develop a jet fighter for half the cost in half the time. And so we've been looking at how the industrial metaverse could support that activity. And the final highlight is taking the industrial metaverse into the Amazon jungle. So we were invited to participate in a project that's led by the University of Alberta in Canada and the University of Campinas in Brazil, where we've applied for funding for a project called Community Wind. And the idea is to supply energy to vulnerable communities. And so this picture of a tribe in the Amazon jungle is one of the communities that, if funded, we would be supporting. And the idea is to take wind power. So you can see on the left-hand side there, a wind turbine is to take wind power into these vulnerable communities, but use the industrial metaverse to show and as a means of communication to show members of the community what the wind turbine would look like and allow them to site it in a particular location. So how do you take the metaverse into the Amazon jungle? You see on the bottom left-hand side there, what we've built into the proposal are receivers to connect our metaverse up via the Starlink satellite system. So this is a very exciting project, and we hope that it's funded. So my last slide summarizes a little bit one of the problems. So what I said right at the beginning of the presentation is that the fusion industry community believe that there needs to be a paradigm shift in the way that we carry out our engineering design and construction processes. But if you present this if you talk about a paradigm shift to a CEO or chief information officer of a company, what they see is risk. Yep. A paradigm shift means radical changes to infrastructure, the workforce, and the work culture. But what I like to emphasize is that what I believe that the industrial metaverse offers the opportunity to make the paradigm shift easy. This particular platform, the Omniverse, what it allows is everybody to carry on using their favorite simulation tools and carry on working in the same way that they've always done, in theory, from the individual point of view. But it allows the horizontal integration of people and processes and data. So whilst the engineer can use their existing tools, they can use them in a new way that is collaborative. And we really hope that our project leads to tools and a way of working that delivers a fusion power plant as quickly as possible. So thank you very much for your attention.